You know, there are architects all around us, building these intricate glass houses so advanced they make our best nanotechnology look, well, primitive. And the craziest part? They do it all in a single drop of water. This is the story of our planet's tiniest, and maybe most brilliant engineers. So what if the most sophisticated nanostructures on Earth weren't built in some sterile lab, but were actually grown in the ocean? For 200 million years, these single-celled artists have been creating glass houses for themselves, with a level of precision that makes our best microchips look kind of crude by comparison.
And this isn't some abstract concept, no. These things are real, and they are absolutely breathtakingly beautiful. So let's dive in. Welcome to the world of the diatoms.
Let's look a little closer. A single drop of water suddenly becomes a gallery of living jewels. You start to see these perfectly symmetrical wheels, elegant feathers, intricate little stars. But these aren't just pretty patterns. Each and every one is a masterpiece of biological engineering. This intricate structure, it actually has a name. It's called the frustule, and it's the diatom's masterpiece, a porous, protective shell made of hydrated silica. Now that's basically the same stuff as opal and glass. They literally build their own glass houses, molecule by molecule. And they come in two main designs. First, you've got your centric diatoms. They're the free floaters of the open ocean, shaped like wheels. Then you have the pinnate diatoms, which like to cling to surfaces and have this long, feathery shape that lets them glide around. Even at this tiny, tiny scale, form follows function perfectly.
But this is where the story gets, well, a little strange. You see, the way these glass houses reproduce creates a bizarre, almost impossible biological problem.
Okay, here's what most people never hear about these creatures. Think of their glass house like a small box, with a lid that fits over it. To reproduce, they just split the box in two. Each half then becomes the lid for a new, smaller box. This means that with every single generation, one of the new diatoms is always just a little bit smaller than its parent. And this process just repeats over and over, generation after generation. So you see the problem, right? The crucial question is, how does an entire population that gets progressively smaller with each division avoid just shrinking into nothingness?
Well, nature, of course, has an absolutely ingenious solution, a biological reset button. When a diatom gets too small, it switches gears to sexual reproduction. This creates a special cell called an oxospore, which inflates back to the maximum size and then builds a brand new full-size glass house, starting that whole shrinking cycle all over again.
Now, this incredible life cycle isn't just a biological curiosity. No, it's actually the engine behind a force that has shaped our entire planet.
We all learn in school that rainforests are the lungs of the planet, and that's true, but it's only part of the story. Diatoms, these microscopic glass builders, they produce a staggering 25% of the oxygen we breathe. Think about that. Every fourth breath you take, it comes from them.
But their impact goes even deeper. About 100 million years ago, diatoms just took over. Their population exploded, and they effectively hijacked the planet's entire silicon cycle to build their endless glass houses. And in doing so, they completely re-engineered the chemistry of our oceans.
So they're beautiful. They have a bizarre life cycle, and they literally shape our world. And this is where things get interesting, because we are just now learning how to harness their genius.
It turns out those intricate patterns, they aren't just for decoration. They form a natural photonic crystal, a structure that can bend and manipulate light in really incredible ways. I mean, it's a technology that our best engineers have been trying to master for decades.
So what can we do with nature's own photonic crystal? Well, we can turn it into a hypersensitive sensor. Scientists take a frustule and coat it with this whisper-thin layer of gold or silver. This little trick turns the diatom shell into a tiny signal amplifier. Any molecule that lands on its surface is suddenly instantly detectable, even in microscopic amounts. And the applications for this are just astounding. We're talking about detecting trace amounts of explosives, identifying pollutants in our water supply down to parts per billion, and even diagnosing diseases from a single drop of blood. All of it by leveraging a structure built by algae. And this detail changes everything. It completely reframes how we think about building things on the nanoscale.
You see, our current approach to nanotechnology is what we call top-down. We take a big piece of material and we carve away at it until we have something tiny. It's slow, it's incredibly expensive, and frankly, it's clumsy. But Diatoms, they use a bottom-up approach. They are living nanofactories building perfect structures from the molecule up, for free, using a blueprint perfected over 200 million years of evolution.
Even Charles Darwin was mesmerized by them. He wondered if their only purpose was just to be beautiful under a microscope. And now we know the profound truth. Their beauty is their function.
You know, we spend billions of dollars looking to the stars for answers. But this story shows us that some of the most advanced technology on the planet can be found right here in a single drop of water. It really makes you wonder, what other world-changing secrets are hiding in plain sight?
Thanks for watching. Support BioVellum by liking, subscribing, and sharing. Let's explore the secrets of nature together.